Hello, boys and girls. My name is Latina Gay, and I teach third grade math at Roy Neal Shellen Elementary School. Today, I'll be bringing you Lesson 6 from Module 1. Let's jump right into the lesson, guys. All right, let's look at our objective. Remember, we should never leave class not understanding what we were supposed to learn out of the lesson or what we were supposed to get out the lesson. So let's look at our target. Today it says, I can interpret the unknown in division using the array model. So we've been looking at unknowns for the past two lessons. For lesson 4, we were looking for the size of the group. And for lesson 5, we were looking for the number of groups. So now we're going to use the array model to determine whether we're looking for the number of groups or the size of the groups. And remember what an array is. Does anybody remember? An array is a set of rows and columns, okay? So let's look at what we have. Let's start off with some fluency. Now, I know by now you're like, we do this every day. And that's because if you can skip count, you can multiply and you can divide, because when you're skip counting forward, you're multiplying. And when you're skip counting backward, you're doing what? Dividing, because I've already told you that division is just backwards multiplication. So the better you are at skip counting, the better you'll be at multiplying and dividing, okay? So let's skip count by twos forward, all right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Very good. Now let's go backwards. 20, 18, 16, 14, 12, 10, 8, 6, 4, 2. Very good, guys. All right, guys, now let's count by threes. We're going to go forward and backward. You ready? Let's go. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Now let's count backward. You ready? 30, 27, 24, 21, 18, 15, 12, 9, 6, 3. Very good. All right, y'all, let's look. We have divide equal groups. So the first thing we want to do is we want to find the total as a repeated addition sentence. Now let's look at what we have. We have how many equal groups? We have 3 equal groups. And what is the size of each group? The size of each group is 5. And remember, when we're doing a repeated addition sentence, we want to use the size of the group to make the addition sentence, all right? So let's start here. We have 5 plus 5 plus 5. And this is the easy one because we can count by fives. Let's do that. 5, 10, 15. So we know that 5 plus 5 plus 5 equals 15, all right? Now it's asking me to write a division sentence for 15 divided into 3 equal groups. Boys and girls, what does the number 15 represent? It's very important that we know what these numbers mean. 15 tells us that there are 15 total red circles. And remember when I told you that when we do division, we always start with the total. So what we have is 15 divided by 3 equal groups. So right here our formula is the total divided by the number of groups equals the size of the group. And what is the size of the group in this picture? It's 5, because there are 5 circles in each group. So 15 divided by 3 equals 5. All right, now we want to say the total as a repeated addition sentence for this problem. Let's look at what we have. Let's see how many groups we have first. We have 1, 2, 3, 4, 5. So my number of groups is 5. What is the size of the group, or how many are in each group? There are 3, okay? So now we want to write a repeated addition, and remember we use the size of the group to do that, all right? So what we want to say is 3 plus 3 plus 3 plus 3 plus 3. Okay? So what we can do now is we can count by what? We can count by threes. Let's try. 3, 6, 9, 12, 15. So 3 plus 3 plus 3 plus 3 plus 3 equals 15. And remember, repeated addition means that we're adding the same number over and over. Now, they want me to write a division sentence for 15 divided into 5 equal groups. What does the number 15 represent? That's correct. The number 15 represents the total number of red circles. So we have 15 divided by the number of groups, which is 5, equals the size of the group. And what is the size of each group, guys? 3. So 15 divided by 5 equals 3. All right, let's look at our application problem, all right? And let's see what we have here. We're going to use the RDW method, which means read, draw, and write, all right? It says 20 children play a game. There are 5 children on each team. How many teams play the game? Write a division sentence to represent the problem. Now, does anybody remember what I said about numbers and how they can be hidden? Do you see a hidden number in here? If you were using the cubes method, what would they be trying to trick you? Right here with 20. Okay? Because we would miss that number because we're looking for it to be in number form, and it doesn't always have to be that way. It can be in written form, also a word form. So we have 20 children play a game. So what is 20? What does the number 20 represent? The number 20 represents our total, okay? Now, it says there are 5 children on each team. So what does the 5 children on each team represent? Would that be the number of groups or the size of the groups? Well, let me help you think about it. What do you think about when you think of a team? Do you think size or do you think group? When I think about a team, I think about a group of people. So since we're looking for the number of children on each team, since we're looking for the number of teams, we know we're looking for the number of groups, okay? We know how many kids are on each team. We know the size of the group is 5, but we don't know how many teams there are. So what we can do is we can draw what? We can draw groups of 5 until we get to our total. And what is our total? 20. Let's try that. So I have one team, 1, 2, 3, 4, 5. 2 teams, 6, 7, 8, 9, 10. Still not done. 11, 12, 13, 14, 15. Still not done because what number am I trying to get to? I'm trying to get to 20. 16, 17, 18, 19, 20, okay? So now all my total number of circles is 20 because I know I have 20 children. And I know that the size of the group is 5 because there are 5 children on each team. How many teams are there? How could we use this picture to find out? We could count the number of groups. So let's count and see how many teams played in a game. 1, 2, 3, 4. So how could we write this as a division sentence? Well, remember, I told you when we do a division sentence, we always start with the what? We start with the total. So there were 20 total children. And what other information did our problem tell us? That there were 5 children on each team. So we're dividing our total by the size of the group. And how many groups did we end up with? 1, 2, 3, 4. So 20 divided by 5 equals 4. We've read, we've drawn. Now we need to write. Let's go back to our question to know what we need to write. It says, how many teams play the game? So we would say, spell out the word for, teams played the game. Okay, very good, guys. Let's move on. Now remember what our objective was. Our objective said that we were going to relate division to the array model. And let's remember what an array is. Array is a set of rows and columns, okay? So let's look at what we have here. So what they did was they actually took our application problem and they used an array to represent it. So let's look at what we have. In our problem, it said 20 children play a game. There are 5 children on each team. How many teams play the game? Write a division sentence to represent the problem. Now, guys, let's look at this array and describe the following relationships. The total number of children and the total number of dots. How many dots do we have? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So when we're talking about the relatedness, we know that the total number of dots represents what? It represents the total number of children, okay? Let's move on. Now, what we want to look at now is the relationship. We want to see the number of children on each team and the number of dots on each row. Now, show me rows. If you were in my classroom, you would do like this because rows go horizontal. And show me columns. These are columns. So what they're asking us now is the number of children on each team and the number of dots in each row. So they want us to actually look at the size of each row, okay? So all I have to do is look at one row because I know they're all equal. So I'm going to count one row. 1, 2, 3, 4, 5. So I see that the size of the group is 5. What does that 5 tell me in my problem? What do we already know? That there are 5 children on each team. So the size of the group here tells us how many kids are on each team, okay? And it says the number of teams and the number of rows. Now, remember, when we count rows, we don't go and say 1, 2, 3, 4, 5. There are 5 rows. That's not how we do it. When we count rows, we count it in its entirety. So we will say 1, 2, 3, 4. So we actually have 4 rows and the size of the rows are 5. So what does those 4 rows represent? The 4 rows represent the number of teams that played in the game, okay? Now, knowing that, let's use that information to draw our own array using a problem that they give us. It says draw an array that shows the equation 15 divided by 3 equals 5, where the quotient, that's a new word, where the quotient, that means the answer, represents the size of the groups, okay? So when we look at this problem, we really have to know what each number means, okay? So what I like to do is I like to label those numbers, okay? Now, the easiest thing about this is you know 2 of those numbers and what they mean, okay? I told you that when we do division, what do we always start with? We start with our total. So we know that 15 is the total. So I'm going to put T for total, okay? Now, they also told us that they want the quotient, which is the answer, the number after the equal sign, to be the size of the groups. So I put an S for size. So that leaves 3 to be only one thing. What are we missing here? The what? The number of groups. So that means we have the total divided by the number of groups equals the size of the groups. Now, once I've labeled all this, I can actually use this to make a picture. How many groups do we have? We're going to have 3 rows. And what's the size of each row? It's labeled with a what? An S. We have the size of the row is 5. And what's our total? How many should we end up when we're finished? 15. So let's draw that. Let's start with I like to start with my size, okay? Because I'm going to do 1 row of 5 and I'm going to do it how many times? 3. Let's do that. 1, 2, 3, 4, 5, okay? That's 1 row. How many rows do I need? I need 3. 1, 2. That's 2 rows and 1 more row. Now let's see if everything checks out, all right? My total should be 15. Let's see if we have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. For my n, what does the n represent? That's the number of rows. Let's see if my number of rows is 3. 1, 2, 3. And it also told me that my quotient should be the size of my group, okay? So let's count to see if there are 5 in each group. 1, 2, 3, 4, 5. So it checks out, boys and girls. So we can actually, what we did first, we worked forward and we used the array to make division equations. Now we're using the division equations to make arrays, okay? Just like we did with multiplication. Now, we can also write, with this array, we can also write a multiplication sentence. It says, now write a division and multiplication equation for this array. So we already know what our division equation was. It was 15 divided by 3 equals 5. Now, what would our multiplication sentence be? Remember, there's a set formula. It's the number of groups times the size of the groups equals the total. So let's look and see what we have here. How many groups do we have? 1, 2, 3. Times the size of the group, which is 1, 2, 3, 4, 5, equals the total. How many dots did we have all together? We had 15. So 3 times 5 equals 15. So this array not only can show division, but it also shows multiplication as well. All right, you guys. Now here we want to use this array to answer the question. It says, circle the size of the group for both problems, okay? So when I look here, I see that I have 15. How many groups do I have? I have 3 groups. So what's the size of the group? So I know in my division equation, what number would be the size of the group? It's 5. So over here, it will be 5 also. So what does that reveal about the rest of my equations? We have the number of groups times the size of the group equals the total. And over here, we have the total divided by the number of groups equals the size of the group, okay? All right, let's skip count to find the missing factor, all right? And this will be one of the last things that we do. So we have blank times 3 equals 24. So when you start doing your sprints in 3rd grade, you have to be very careful because sometimes you'll be looking for the answer and sometimes you'll be looking for a missing factor. Now, a lot of my students get confused and this is how I teach them how to do it, okay? So I'm going to show you this and this will be the end. So we have blank times 3 equals 24. All you have to do is skip count by the number you're multiplying by until you get to your total. Now, the trick is you're going to have to track them. And the best way for me to track is to use my fingers. So let's try that. So I'm going to skip count by threes until I get to 24. And however many fingers I'm holding up, that's my answer, okay? So let's try it. 3, 6, 9, 12, 15, 18, 21, 24. Okay? How many fingers am I holding up? I'm holding up 8, okay? So my missing factor in here is 8, okay? 8 times 3 equals 24. How many threes make 24? So in other words, they're asking, how many times did we count 3? We counted it 8 times. Now, we can actually use this to make a division equation also, all right? So, what's my total? It's 24. And I was trying to find out how many threes make 24. So, 24 divided by 3 equals 8. That's all I have for you today, boys and girls. I hope you enjoy my lesson. I'll see you tomorrow for lesson 7.